Hello. I wanted to show you a script that I've been building. I started building it because it was really raining outside here in Copenhagen. So I wanted to make some efficient use of time, and I was building a script. So I'll try and show you the script I built here. My interest for OpenStreetMap started because I wanted to map out all of the available drinking water in Copenhagen, or wherever I was. But primarily Copenhagen, where I'm biking around a lot. So I wanted to know where I can fill up my water bottles. So I noticed that there's a lot of different ways of describing drinking water in OpenStreetMap. So there's all these different tags that you can use. So that's really scary to use as a first-time user. And after I started mapping these things out into an application that I could use, I wanted to figure out how I can contribute myself to OpenStreetMap. So I found a nice application here called Street Complete. It's only out for Android, but I can kind of show you how it works here. So you open up the app, and then you get presented by these bubbles here, and they will give you different questions. So this is a bin, and you can answer here, but you can leave here for recycling, and that will actually live inside of OpenStreetMap after that. So there's some restrooms here. You can say if it's wheelchair accessible, and you can see buildings here. So you can tell them what the primary use of this building is. So OpenStreetMap would know if it's residential or if it's a commercial building or whatever. So it's a really nice way of giving back into OpenStreetMap, and everyone else can start using that data as well. I follow a guy on Twitter. He's called Søren. He had an idea that he wanted to know all the surface levels of all the bicycle paths in Copenhagen. So he created a map called InOverpass, like this, and he made a query. So you can see here, I've modified it a little bit. So it looks in Copenhagen Council. It searches the area, and it looks for highways that are marked as cycleways. And that's missing a surface or missing a cycleway surface. That's just some technical lingo that the OpenStreetMap uses. But if you zoom in, we can see the different bicycle paths. You can see here, there's one here. We can try and click it. We can click it away here. So here we can see all the data that is available to that one object. We can see the only tag that has is that it's a highway and it's a cycleway. There's nothing to tell us what sort of surface that is on this. So if you knew, you could just go in here and OpenStreetMap, press edit, and go ahead and put the surface on. But for me, I wouldn't be able to do that because I actually don't know what the surface level is. So for me, I would open up Street Complete. I will take my bike out and I will go to this place, and I will tell Street Complete what the surface level is. And that can take a lot of time because, as you can see, as you can see here, there's a lot of different ones. So if I didn't have an efficient path between all of them, I could waste a lot of time just driving around if I haven't got an efficient route. So my idea was to figure out a way where I could find an efficient route between the nodes. Maybe not all of them, because that would take maybe 24 hours, I don't know, a long time. So if I could focus on a subset of them, then I could do it in weeks. Focus on maybe these ones. These ones first. Go and close all of them. Then the next day I could go focus on these ones here. You get the idea. So I found a really cool service called OpenRoute service, and it does a lot of cool stuff with OpenStreetMap data. And you can use the APIs for all sorts of stuff. You can do directions, elevation. There's some optimizations you can do as well for routes, and that's exactly what we want. They use something called Room, which is an API, but they host it, so you can just ask their servers, and they have they're really generous plans. It costs nothing. But they have some user limits here. So you can see the one I want to use is called optimization, and I can do 500 requests per day. So that's very generous for me because I don't need to ask them a lot about my routes. So if you go back to the API that's called the optimization API, you can see that it's very technical. It's not really built for my sort of use case. The use case it's built for is some people that have to deliver a lot of packages, and they have a lot of different cars, different vehicles. Some of them might have bicycles, some of them might have cars or vans. And all of the drivers have different required skills. They have different capacities based on if they're a van or bicycle. They also have time windows, which means that they might start working at 9, they go home at 3, but they also have like a break in between and all that stuff. So there's a lot of advanced stuff in this API, but luckily we don't have to focus on all that for me to find my solution. So if we go into to this, we can try and go through my script that I've built. So if I just focus on a subsection, so I would just focus on these nodes here. I can go up here and press export, and I can take the data out, and I can copy it as GeoJSON. And then I can open it up in my editor. Oh, where's my editor? There it is. And I want to call my file export.json. Oh, GeoJSON. There we go. So I'll take the whole file here. So what my script does is it's a Ruby script. It just have a few gems here. I use Haml, I use active support for some time calculations. I use Pry to show you a debugger in a second. So the first thing we do is that we just load in the JSON file and pass it as JSON. Then we just take all the different coordinates. We only take the first coordinate for every feature that we get. It's a bit technical. Oh, wrong button. It's because if you have a look at some of the data here, you can see this is called array, and the array consists of different nodes. So you can see this one, the start might be a node. This might be a node, this might be a node, this might be a node. So this is probably 4 nodes. And I actually don't care about all the different nodes. I just care about one node, because then I know where I can find it, and then I can just put the data in. I don't care about all the 4 different nodes. So that's the idea behind that. Also, there's a bounding box. That's because the GeoJSON that has been returned from this API here is all of the data points here, and I actually don't care about all of them. So what I can do instead is that I can use a bounding box. So I can go in here and I can say export and go to map, and I can go to map view. So this will tell me the bounds of my current viewport here. So I can just copy paste the first coordinate here, put it into my bounding box variable here, and take the second one. Oh. Put it in there. So this is my bounding box right now, and then I do some data manipulation here, where I figure out what's the smallest one, what's the largest number, and then I just filter all the coordinates. So when I have all my coordinates, then I just exclude all the ones that are outside of my bounds. Then I have a max amount of coordinates that are saved here, and that's because there are some usage limitations of both the optimization API here. I think I can only do 50 jobs at a time, but if I want to pass the route into Google Maps later to actually give me a route on my phone that I can drive, then there's also a limitation of how many stops I can have there. So I've just set it to 25, but it might need to be lower. That's just something to work with for now. And then I just throw in an exception if I found more than the max amount of coordinates that I need. Then I start building my problem. The problem actually goes into the API. You can see I only have one vehicle. I just give it the ID of 1, but I've had same start position and end position, and this is where I rent my bike. And then I just tell the API that I'm on a cycle. Then I start to define the jobs. So you can see the jobs actually doesn't have to be as elaborate as they are here. You can see the jobs here. There's like service, some time windows, all sorts of very advanced stuff, and we don't really care about that because we just have to visit all of the nodes. So what we add is just we give it an index, we give it a location, and that's it. And then we send, then we have the problem defined. Then we take the API key from a file that I'm not going to share with you, and then I send off the request to the OpenRoot service. And then I take the data out of the service again, and then I just do some rudimentary checks. So that is, are there any unassigned jobs? For me, I don't have multiple drivers, so it would be really weird for me to have something that's unassigned. And also, I don't have more than one root because I only have one driver. So if there's more than one, I will throw an exception. So that's just some, I don't know, checks that you will have with the output just to make sure that everything is sane. So then I take all the data and I start putting it into an open struct. And I do this because I wanted I want to have some HTML that I can present myself with, and also I wanted to just make it a bit nicer to work with. So this is why I have active support in. That's because I want to have some nice durations. So instead of just having all in seconds, I can print it out in minutes or hours and minutes. So that's what this is. So then I go through all the root data. I add open structs. Just go through the step. Step is like start, stop, or end of the root. Then I go through the longitude and latitude and arrival time that is nicely presented. And then I just also include it in seconds. And then I render an HTML template and I write it in HAML, which I prefer. I'll show you how that looks here. So this is a HAML file. It just renders as HTML. It's just nice to look at, I think. As you can see, I create some links for that goes to Google, like a specialized path here. But basically, I just root through all the data and print it out. But I'll show you how it looks when we go through the project. So as you know, I've already downloaded the file, so I'll just run the script and step through it. Didn't I save? That happened. There we go. All right, so we have all our filtered coordinates here. That's good. Then we have defined our problem. That's the one we are sending off to the API. So we have one vehicle here. We have my starting position. We have all the locations here. Now we have the output from the web service. So you can see the root data here. This is what we get back. We get the cost. The cost is the same as the duration. So this is how much time in seconds it will take me to solve. There's some computing times. That's probably how many milliseconds or whatever it took the backend to calculate my route. You can add some waiting time. So you can say maybe it takes 5 minutes every time I do a delivery. But I haven't calculated that in. Just take that it takes 0. So when I arrive, the API assumes that it only takes me 0 seconds to map the whole thing out before I go on the bike again. That's not right, but it's simple enough. That's all right. So from here, it has calculated the file. You can see here we have the root.html file. So I'll try to open that up in Chrome. Here you can see the HTML that the script has outputted. You can see that there's 11 stops, and then there's a start of the journey and an end of the journey. And you can look at these just to see individual stops in Google Maps. If you click the mobile link, it will open up directly in Google Maps. If you have it on your phone, on a computer, it won't do anything. But you can also just click the Google Maps full journey if you want to see how long it will if you see the journey, you can send it to your phone if you want to. So you can see here's the full journey. It will take 56 minutes by car. We go by bicycle. So we can see here how long it will take. It will take 1 hour and 1 minute. So you can see our API thought it would take 58 minutes. And Google thinks it will take 1 hour and 1 minute. So it's probably somewhere in between there. So when you have it up here, you can see everything looks same. You can see we return to the same place as we started. So that's actually what we wanted. And there's a button here where you can send directions to your phone. That's really cool. I actually just download this file on my phone, and then I go out and go one stop by stop. But it's really cool that you can also just send it to your phone, and you could be on your way. So that's it. That's my script. It will be available on GitHub, so you can run it yourself, and hopefully we can get some of all these. Oh, can I find it? Yeah. Hopefully we can get some of all these surfaces fixed, so we can have more data into OpenStreetMap, and we can all go out on our bicycles and have some clever paths generated for us.